All right. As I mentioned yesterday, there are two different ways for us to multiply vectors. Yesterday we did some work with the dot product. When we multiply two vectors using the dot product, what kind of answer do we get? A number. Okay? Well, wouldn't it be nice if we could multiply vectors and get a vector? Well, whatever you think, we're going to do it. Okay? So we're going to have a vector u and a vector v. And when we evaluate the cross products, don't write anything down. Let me just show you. Okay? When we take u cross v, we're going to put three rows, into a 3 by 3 determinant. The first row is always ijk. The second row is u, and the third row is v for u cross v. They have to be in that order. Okay? Go ahead and write down what you need to, and then we'll talk more. So you have to be specific when we're talking about multiplying vectors because u dot v is very different than u cross v. Okay? U dot v gives us a scalar, u cross v gives us a vector. Yes.
Does this only work with three-dimensional vectors, or can it use?
Yes. It only works with three-dimensional vectors. We're going to get to some of its properties here pretty soon, but we're going to go ahead and do an example. Okay. The reason I did this up here on the board is so that we could remember how to evaluate a 3 by 3 determinant. That's what we're going to have to do to find our cross product. Since our first row is ijk, then our determinant is going to have ij's and k's in it, and we will result in a vector. Okay? U cross v is not the same as v cross u, but we will look at both and see if there is a relationship between the two. Maybe there is, maybe there's not. Okay? This is the reason why, this is one case where the form using ij and k is beneficial. We cannot do the cross product without the ij and k. So I know some of you find it kind of annoying that we have two different forms and you don't see the point of it. Well, here is one reason why we have the ij and k. All right? So go ahead and write down that u is 6i plus 2j plus k, and v is I plus 3j plus k. So to evaluate the cross product, ijk is our first row, and then just the coefficients, just the components for u and v go in the next two rows. So since this is u cross v, we're going to put 6, 2, 1 in for the second row, and 1, 3, 1 in for the third row. Okay, so to evaluate this determinant, we will copy paste the first two columns, and we'll do our crisscross applesauce here. So first we have to do the down diagonals. So I times 2 times 1 plus j times 1 times 1 plus k times 6 times 3. Then we will subtract all of the up diagonals. So going up, we have 1 times 2 times k plus 3 times 1 times I and 1 times 6 times j. So now we can essentially just combine like terms. So we'll start with the i's. We have 2i minus 3i. We have j minus 6j. And we have 18k minus 2k. There is our U cross V. Now, the cross product, unlike the dot product, is not commutative, which means V cross U will be different. So let's go ahead and set up V cross U together, and then I want you to do the work without me. So V cross U, we are always going to have IJK for our first row, but now V needs to be the second row and U our third row. All right? So I'm going to give you about a minute and a half to go ahead and do the calculations for V cross U. Are you noticing any patterns? Your number should be similar. And Marissa, what did you get?
I plus 5i minus 16k. I mean j.
I was going. Hey, Marissa got I plus 5j minus 16k. I can't even say it right. Do you agree? Okay. Basically, when you do the calculations, these two like switch, right? And what you got up here, these two switch. What do you notice about V cross U compared to U cross V? And what do we like to call that? If they're just opposite, okay? Do you think that this is a coincidence? You think so? It actually is not. Okay, I would not write these down. Okay, I would maybe write down that U cross V equals the opposite of V cross U. That is something that is important. Okay. But then I'm just going to go through some properties, and honestly, I think some of these are intuitive. They're also written in your book, so I would not waste the paper or your hand muscles on writing them down, because you can reference them in your book if you need them. Okay? Our second property. This is basically the distributive property. If we have u crossed with v plus w, we can take u cross w and add it, u cross v and add it to u cross w. That's all that's saying. Okay, the cross product is like multiplication, so we're going to treat it as such. We had a similar property with the dot product. If you have a scalar multiplied to your cross product, you can either do the cross product and then the scalar, or you could do your scalar to one of the vectors and then the cross product. Okay? More than likely, you're just going to do the cross product and then worry about the scalar to keep your numbers small. Okay? U cross 0 is 0. All right, if you have a row of zeros in a matrix, the determinant's going to be 0. U cross U is 0. Okay, that's an interesting one. Okay, if we look at a determinant with U and U, right, then what's going to happen? Your diagonals are all going to be the same, and so when you subtract them, they're going to cancel out. Okay, so U cross U is 0. And then finally, and we'll talk about this one here a little bit more later, but U dot V cross W is the same as U cross V dot W. Okay? What do you get when you do a cross product, a vector or a scalar? A vector. And then if we have a vector dotted with a vector, we get a scalar. So it doesn't matter which multiplication you do where, if you have both of them, it doesn't matter the order of the multiplication. I think that's simple. But we'll talk about what this is called towards at the end of the lesson. Okay? Now, we all love geometry. We all love physics. How many of you know what the right-hand rule is? And you do something like this. I don't know how to do it with my hand. Someone do it for me.
Your fingers go with the force or the first. Depending on it. Yeah. Like you go to the direction of the electron or proton. And then like your fingers curve the way that the electric field goes.
And there's your thumb.
Force.
Okay. So what's true about your thumb compared to your hand and your arm when you do the right hand rule?
That's like the force effect.
Okay, what kind of angle is it at? Anybody?
It's perpendicular.
Okay, so your thumb is the cross product. When you take the cross product, it becomes an orthogonal vector to both U and V. This is the right-hand rule for those of you in physics. Okay. The cross product is orthogonal to both vectors, which is very useful when you're working with a lot of different things. Okay, now, if we have vectors that are orthogonal, what's true about their dot product? It's 0. So, in the last example, we had these two vectors, correct? What did we get for U cross V?
Negative I.
Negative I?
Minus 5J plus
16K. Okay? So if we take U and we dot it with U cross V. Then we take -1 times 6 plus -5 times 2 plus 16 times 1. Our dot product is 0. We have orthogonal vectors. Let's do it with V. If we take a dot product of V and U cross V, then we take -1 times 1 plus -5 times 3 plus 16 times 1. Okay? Yeah, orthogonal vectors. Isn't that cool? Okay. Now, what can we do with that knowledge? Actually, the first thing we're going to do, well, I guess this isn't really, when you get into Calculus 3, we talk about like a three-dimensional parallelogram. And so being able to find the height of a three-dimensional parallelogram, we use with the cross product because it gives us an orthogonal vector. Okay?
Very careful.
Something else that we can use the cross product for is if we have two vectors that create a two-dimensional parallelogram. Then we can take the magnitude, thank you, that word left me, the magnitude of the cross product, and it'll give us the area. I do have a proof for this, but I don't think we have enough knowledge about vectors to understand it, so we're just gonna, it's the end of the year, we're just gonna accept it. Is that okay with everyone?
No, we accept.
We accept it. Whatever you see. Once.
It's not 12:20. When my clock says 12:25, I will release you. You may go to lunch. My watch is synced up with the bell, so when mine says 12:25, then I will let you go. And it does now, so you may go. You're welcome. Okay, so if you are given two adjacent sides of a parallelogram, you can take the cross product, and by finding its magnitude, it will give you an area. Okay? Now, magnitude is a length, so it's always going to be a positive number, which makes sense for area. All right? So on the next slide, I have two vectors that make a parallelogram. Please write them down. And then we will go through the process of the area together. So the vectors, I plus 2j plus 2k and I plus k are the adjacent sides of a parallelogram. So the first thing we want to do is find the cross product. Doesn't matter in which order we take the cross product.
Oh,
Why no?
because it'll be like the same numbers, just like flip sides, because when you do the magnitude, it's gonna be positive anyway.
Okay, U cross V and V cross U are opposites. And since they're opposites, their magnitudes are going to be the same. So it doesn't matter the order in which you put these in the cross product. You may get opposite vectors of somebody else, but we're finding the magnitude anyway, so it doesn't matter. So I, J, K, we'll just go in the order of the first one, 1, 2, 2, and then the second one, be careful, this is 1, 0, 1, because it's I plus K. All right, so we will copy the first two columns. do our crisscross here. So down diagonals, I plus I times 2 times 1, j times 2 times 1, and k times 1 times 0. Minus the up diagonals, 1 times 2 times k, 0 times 2 times I, and 1 times 1 times j. So our cross product will be 2i minus 0, 2j minus j, and 0 minus 2k. So our cross product is 2i plus j minus 2k. Do you agree with all those calculations? Okay, good. So now the area of our parallelogram will be the magnitude of that vector, which is the square root of 2 squared plus 1 squared plus negative 2 squared. What's our area? Oh, I'll put it there.
3.
But I do like the unit squared. Okay, so it's important to show your work, Gabe. Okay? Are you ready? For the last slide. Okay, so we're going to talk about what's called the triple scalar product. Okay? Let's talk about U dotted with V cross W. If we have 3 vectors and I wanted you to find U dot V cross W, you would have to do the cross product. We know how much work that is. You get a vector. Then you can take the dot product between what you got and U. It's like a 2-step process, right? What if I told you it could be a 1-step process? You'd be excited, right? Okay? If we have U dot V cross W, we call that a triple scalar product. And all you have to do is, in order, put them in the determinant. U, then V, then W. This determinant will give you a scalar, which makes sense because we have a dot product, essentially, that we're finding. Cross product gives us a vector, then we do the dot product to give us a scalar. And that's what a determinant is going to find for us, a scalar. So we are going to find the triple scalar product of these 3 vectors. Go ahead and write them down if you'd like. Go ahead and put names on them. So our triple scalar product, we're going to go ahead and put these into the matrix. So we'll put U in the first row, V in the second row, and W in the third row. Makes it nice because we have all numbers. There's no I, J, and K. That's a 2, isn't it? Is that what you're telling me? Thank you. All right, so copy paste the first 2 columns. And we'll do our diagonal. So down diagonals, the first one we have 4 plus 0 plus 15. Subtract the up diagonals. 1 plus 20 plus 0. So we have 19 minus 21. Our triple scalar product is -2. Okay, everything that we've done today has been new, so it's very important for you to do your homework. I'm going to give you this opportunity to start your homework, but I expect this to be done when you come back on Monday. Monday you will get a review. I'm hoping that you can get a majority, if not all of the review done in class Monday, and we'll go ahead and take our test on Tuesday, because I know a lot of you just want it out of the way, and then I'll reward you with something on Wednesday. We'll have an exciting day in here Wednesday. I'll just put it that way. Okay?
It involves food because I don't know.
Oh, food
This is our lunch period.
Oh, yeah, we should have a